Today we will discuss an important data analysis technique, that is discriminant analysis. Discriminant analysis is a technique to see whether the groups are same, different, and what is their score. What is the difference and similarities between ANOVA, regression, and discriminant analysis? See, ANOVA. What is the similarity between ANOVA, regression, and discriminant analysis? In ANOVA, regression, and discriminant analysis is the number of dependent variable is 1. That is, grouping which we are going to make it is one variable. But number of independent variables in ANOVA, regression, discriminant analysis are multiple independent variables. What are the differences? Number of dependent variables in ANOVA is metric. What are the actual values you have observed? In regression also it is metric. Whatever the observed value is there, you are going to take it as it is. But in discriminant analysis, it is going to be categorical. Category 1, 2, 3, 4 category. In case of independent variables in ANOVA, it is categorical. But in regression and discriminant analysis, it is metric. In regression also, independent variables are metric, and in discriminant analysis also it is metric. So in discriminant analysis, our dependent variable will be categorical, but our independent variable will be metric. Now here, what is the difference between logistic regression and discriminant analysis? In logistic regression, the categories we take only 0 and 1. It is just like dummy variables. And independent variables, they are metric. And in logistic regression, we get the probability. What is the chance that this event will happen? But here in discriminant analysis, we get a score. What the score is, person is going to get it. Discriminant analysis is a technique for analyzing data when the criterion or dependent variable is categorical and the predictor or the independent variables are interval in nature. The objectives of the discriminant analysis are development of discriminant function or linear combination of the predictor or independent variables which will best discriminate between the categories of the criterion or dependent variable. As in regression, we get the equation. Similarly, we will get the discriminant function here. Examination of whether significant differences exist among the groups in terms of predictor variables. Determination of which predictor variables contribute to the most of the intergroup differences. Classification of cases to one of the groups based on the values of the predictor variables. Now here we can decide where is the benchmark, where is the level where we can break that this event will happen and this event will not happen. It is not probability but the score. Evaluation of the accuracy of the classification, whether the classification which we are doing it with discriminant analysis, how much it is correct. When the criterion variable has two categories, The technique is known as two-group discriminant analysis. We will get only one function. When there are two categories, we will get one function, and it is called two-group discriminant analysis. When there are three or more categories are involved, the technique is referred to as multiple discriminant analysis, and we will get more than one function. Then you have to see which function is significant, which function is good, or which function has good results. We will use that function. Rest of the functions, if they are not significant or not giving good value, good scores, then we will discard them. The main distinction is that in the two-group case, it is the possibility to drive only one discriminant function. In multiple discriminant analysis, more than one function may be computed. However, not all the functions may be statistically significant. How we conduct? Identify the objectives. Why you want to do discriminant analysis? What are the criterion variables? And which is the independent variable or variables? Criterion variable, which is your dependent variable. Criterion variable must consist of two or more mutually exclusive or collectively exhaustive categories. The predictor variables should be selected based on theoretical model or previous research or the experience of the researcher. One part of the sample called the estimation or the analysis sample is used for estimation of discriminant function. The other part called the holdout or validation sample is reserved for validating the discriminant function. What are the important tests? First one is Wilks lambda. Wilks lambda is a measure of how well each function separates cases into groups. It is equal to the proportion of total variance in the discriminant scores not explained by differences among the groups. Smaller values of Wilks lambda indicate greater discriminatory availability of the function. Smaller values of the Wilks lambda indicate greater discriminatory ability of the function. Next test, box-M. The box-M, this tests the null hypothesis of equal population covariances matrices, whether the variances, covariances matrices, they are equal or not. Let us practice it on SPSS. We will load a file. We will first practice it with the two categories, only two, and then we will have the multiple discriminant analysis function, both, and then we will try to interpret the results. Let us see a work file with the variables age, distance from home, education level, environment satisfaction, which has come out from the survey, gender, male, female, job level, which level he is, junior level, middle level, higher level. There are 4 levels. Job satisfaction. So there are 4 levels here also, whether he is satisfied, not satisfied, very high satisfied. Monthly income, and then percentage salary hike, total experience, and year with the present post. We will load this file in SPSS, and then we will work on this with the discriminant analysis. We can recode this, the gender. We can say okay, and we can say gender code add new name, and it will say the lowest as 1 and highest as 2. So we can say OK. So female have been named as numbered as 1 and male as 2. We need not do it as 0 and 1 in case as in logistic regression. We can do it 1 and 2. There is no issue in that. So let us see now discriminant analysis. We'll go to analyze. We'll go to analyze, and then we will go to classify. In classify, we'll go to discriminant, and we want to discriminate with grouping variables as gender code. We'll take it as gender code, and we'll define the codes as minimum 1, maximum 2. So it will say OK, and we can take the this independent variables is distance from home, education level, so they are all numericals, environment satisfaction, job levels. See, there is no need to take all the variables. You can take the variables whatever you want it. The way you want it, you can take it. So these are the independent variables. Okay. So we can have the statistics also. In statistics, we can get the means, leave it. Then we can go to classify. Classify, all groups are equal and other things remain same. Okay. And then we can save. We will save discriminant score. You can also, if you want, you can make the predictive group membership, or you can make it probabilities for the group membership. Probabilities are usually calculated with 0.5. If it is less than 0.5, it will fall in one group, and if it is more than 0.5, it will fall in another group. That probability is there. So we will say continue, and we will say OK. Now we have got the results. This is first table is just to count how many numbers are there, and then the second table is group statistics. It tells us about the mean of each independent variable with the category, that is male and female. Female, for instance, age is mean is 37.99 with a standard deviation of 9.797. Similarly, in case of male, the age is 36.17 with a standard deviation of 8.99. So you can say male are younger, female are bit older. The distance from home 9.16, distance from home is 9.06 in case of female. So we can also see the total means, total standard deviation. Now we come to the test of equality of groups of means. So we can say age is statistically significant, 0.033, and distance from home is not statistically significant because it is more than 0.05. Education is statistically significant in discriminating. Environment satisfaction is not statistically significant, and we have got the other significant variables: job satisfaction, monthly income, total experience, and year with the present post is not statistically significant. Boxes M, first log determinants have been calculated, and then we have got boxes M. Now boxes M is for null hypothesis, equal population covariance matrices. So value is significance value is more than 0.67. It means there is a null hypothesis accepted. So all covariances are equal. Now we come to this canonical discriminant function, and eigenvalue is 0.038. So it covers everything. Now comes to the Wilks lambda. Wilks lambda tells us whether the two groups, they are really discriminant, there is a difference. So we say significance value is 0.048. It means there is a discrimination. but this lambda is 0.963. Now we have got the standardized canonical discriminant function coefficient. Standardized means this functions coefficients have been divided by standard error. These are the now structure matrix has been given. Now we come to the directly our canonical discriminant function coefficient. This is canonical discriminant function. This is used for, this is unstandardized, and this is used for calculating the discriminant score. Now with this discriminant score you can decide which at what level the score crosses the certain limit. So then you can decide which group certain people fall. Then we have got the functions group of centroids, may or may not be useful to you, and then we have got classification function coefficients for female and male separately have been given. These are the Fisher's linear discriminant functions separately have been given. Now let us see now how we calculate the discriminant score. So let us see this one. SPSS is already calculated, but how it has been calculated? Just like regression, I will put this function here, copy it here. Okay. Now this is the canonical discriminant function which I have copied it from here. So let us see the first one. The first one is see, this one, age is 41, distance 1, education 2, this male female we have already taken it as a grouping. So we will say this one copy, I am going to paste it here. Okay, and then I can paste, copy these, and then this one. Now I will multiply it. Now constant is taken as 1. Now I will multiply it sum product, this one, this function which have been created by SPSS, comma, multiplied by our values, so this is coming, this up to 16. So this is coming as minus 1.03097. Let us see when we give the command to save this. So SPSS might have saved it as a variable. So let us see this one. Yes, this one is our discriminant score for observation number 1, minus 1.03097. This I have shown you how we have calculated. This has been calculated from the canonical discriminant function coefficients. Okay, so these all they have been calculated. Now you can take it in Excel sheet and you can see, arrange it, sort it out, and you can see where actually the breakup comes. And there is also if you go to analyze, there is a analyze and discriminant score. Sorry, no, this will not come there. Now if you save it here, saving, you can say predicted group membership, what is predicted, and then you can see the probabilities of group membership. That also you can see it. Okay. Now this is only 2 categories, male, female. Now let us work on another example. Resetting everything. Let us work on another example, which I will say job satisfaction. Now, is there any difference between the job satisfaction? So there is a range of 1, minimum 1, maximum 4. I'll say continue, and now I will not put all the variables. I will put only few variables: age, distance from home, education, and then environmental satisfaction, and then I'll say total experience. Let us see, don't put all the thing. Whatever is required, you can put it. Okay. In statistics, we will use means, univariate, ANOVAs, Boxes-M, Fishers, unstandardized, and then I will take classify, all display case-wise results, summary. We can also put the number, how many cases you want, and then I can say save. I can put predicted group membership, discriminant scores, probability group membership. Discriminant scores will come now many functions, because I'll show you, because now we have got 4 categories, at least there will be 3 functions. Continue. I'll say okay. Now the results are there. Now in the same way, group statistics is there, where mean of each variable under each satisfaction level is calculated, and then total is also calculated. Test of equality has been calculated with the ANOVA, that is F has been calculated, and then Boxes-M has been shown, and Boxes-M also say there is equal covariances, and then we have got eigenvalues calculation and all, and then comes Wilks lambda for 3 functions, 1 through 3, 2 3 through 3, and 3, because we have got 4 categories. But one thing is there, all these functions are not statistically significant. All these functions are not statistically significant. So Wilks lambda says there is no much discrimination. There is no discrimination in the 4 groups. Now these are the standardized canonical discriminant function coefficients, which will for each function, which will be used for calculating the Z score. But as I have already, none of the function is there. None of the function is statistically significant, so there is no fun. But even then, if it is there, so as I have already told you, you can use this to calculate the Z score. These Z scores have also been calculated by SPSS, and I will show it to you now. See this one. See this, already we have already calculated this one, so we could not delete it. It's already there, which we did it in the earlier one. That is not deleted, it is there. You can clear it, you can say we don't need it, but now this one is there. Probabilities. Now first one is probabilities of falling in category 1 is 1, 2 is 1. So it is saying, actually it is a male, but it should have fallen in the it should have fallen in the second category, not male female, but satisfaction level. So this is the discriminant score 1, this is the discriminant score with function 3, 2, and this is function 3. So all the function level scores have been calculated for you. Thanks for watching. We will discuss more statistical tools in the coming videos. Thank you. You may submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments